Alright, welcome to my channel, math_exe. Today we're going to look at how to solve quadratic equations by, what is it called? Completing the square. Wait, I'll write this first. And now basically what this means is, given you have like a quadratic equation ax squared plus bx plus c equals 0, and what you need to do is you add something to it to make this a perfect square. I'll show you what I mean later in the example. So let's look at an example of x squared plus 6x plus 8, something like that. And we call the factoring of a perfect square such that, like, in the form of a squared plus 2ab plus b squared, this can be factored as a plus b in the parentheses squared, like so. So this is the essential tool for this kind of completing the square thing here. So what you need to look at is, we look this x squared term as the a squared term, so I will write down right here, and this 2ab with this 6x, so yeah, the same thing. However, this b squared will not look it exactly equal to 8, but we're going to look at what exactly b squared needs, so and what I mean is what we need to add so that it makes it a perfect square. So yeah, so first we set this equal to each other, and we'll solve for a and b, and then we can find what b squared is supposed to be, and then we'll find, oops, I forgot to add plus 0 equals 0 here. So yeah, I'll go down here and let's see, a squared plus, a squared equals x squared. We can take the square root on both sides real quick. You can get a equals plus or minus x, but you really don't need to use the plus or minus sign. You can check that on your own. You can like just play around with this type and it really doesn't even matter. Yeah. So in this case, I'll take the positive x, and then we'll move on to, wait, I'll move the board, 2ab equals 6x. So let's see, 2ab equals 6x, and note we got a equals x, so we can substitute a as x right here. So we can get 2xb equals 6x, and we can divide both sides by 2x as follows. This divides that and this divides that, leaving us with a 3, which gives us b equals 3. And coming up on the board, upper board here, we get that this, I'll write down right here, b squared, and this b squared must be equal to 9 in order this to be a perfect square. I will just rewrite the quadratic equation right here below. X squared plus 6x plus 8 equals 0. And what we do is we need to add a constant so that this term, wait, I will remark this term right here becomes a 9, and what added to 8 gives 9? Of course, it's just 1. So what we will do is to add plus 1 on both sides, like so, and then x squared plus 6x, 8 plus 1, of course it becomes 9. This just becomes 1, like so. Okay, now we call on here, we have the following equations: a equals x and b equals 3. So we're actually given that this is a perfect square, so we can just factor as follows, like on the formula here. We know that this is equal to x, this one is equal to 3, adding up, and yeah, so you can rewrite this on the back right there. So we get x plus 3 squared equals 1. And of course we can take the square root on both sides. The square root with this square will cancel, this one will be here, and don't forget the plus or minus sign right there, and we get x plus 3 equals plus or minus 1. And I'll divide this into two cases where this, wait, I will write both arrows like here, is it can be either x plus 3 equals positive 1 or x plus 3 equals negative 1. And of course you can just solve this real quick, and you can get that this here, x equals negative 2, and here we can get that x equals, yeah, negative 4. Yep, I'm pretty sure I got, yep. So this is the answers for our original equation. Wait, yep, right here. So we got our solutions: x equals negative 2 and x equals negative 4. Now you can check real quick that these both work if you want it, but I won't do it for the sake of this video. Let's try another example, like, wait, I'll think 2x squared minus 6x minus, I'll think another example, 2x minus 10x minus, wait, plus 6, wait, plus 12, I think. Yep, this is equal to 0. Now we're going to solve this quadratic equation, and we'll just rewrite our formula right here for the factoring of perfect squares, like so. There we go. So we're going to look this as this as this, and we're going to find what b squared is supposed to be and what we're supposed to add right here. I'll put a question mark here. So setting these equations up, we got a squared equals 2x squared, squaring both sides. We got that a equals plus or minus square root of 2x squared. Now we encountered to a problem. When we substitute this into this formula, we get like an irrational number inside a nested square, like so, and that really kind of screw things up. So yeah, this strategy won't work. so we have to figure a new one. So what we'll do, wait, I'll erase this equal signs of that stuff. Okay, so what we'll do instead is, let's try to factor out a 2 out of this. So we'll get 2, and what's left after factoring out a 2 of this term, we get x squared. What's left after factoring a 2 out of this, we got negative 5x, and what's left on here is plus 6 equals 0. And we can divide both sides by 2 to get this 2, and I'll slide the board down. So you get x squared minus 5x plus 6 equals, equals 0. Well, 0 divided by 2 is just 0, so yeah. Okay, next we're going to set up our a squared plus 2ab plus b squared. Okay, so we're going to set these two terms equal to each other, and just so you're not confused, I will repair this 6 a bit. Wait, there we go. Okay, so later we'll figure out what b squared is supposed to be, so we can factor this out as a perfect square. Okay, so from this equation we got x squared plus a squared. We can quickly get that x equals, well, we don't really need a plus or minus sign, so we'll just assume that it is positive a. And from this right here is negative 5x equals 2ab. Substituting x equals a into this, we get negative 5x equals 2xb. And I'll slide the board down. Sorry for the bad drawings. I mean, right things. What am I talking about? So you can divide both sides by 2x, like so. This and this will eliminate each other, and this will leave us with negative 5 halves, just negative 5 halves. So we can get that b equals negative 5 over 2. And we can get also b squared, which is what is our value is supposed to be, equals, squaring both sides right here, we get, I will just rewrite this here, and then we can quickly get this as, you can 25 over 4. We'll just leave it in this this improper fraction, but if you really want to change it into a mixed fraction, it's also fine. So coming back here, this is our perfect square. We're supposed to look fine. We get that b squared equals 25 over 4. And I'll rewrite the equation down here. Okay, wait. Okay, so x squared minus 5x plus 6 equals 0. Okay, so we'll need to add a certain constant that when added to 6 will give 25 over 4. And when you think about it, adding a quarter will work. As you can see, when you add 6 to a quarter, you get 6 1 over 4, and then when you switch it into an improper fraction, you get 1 over 4. So let me rewrite it again. X squared plus 5x plus 25 over 4 equals to 0. Now, okay, we already find what our a value is. so x equals a, and we also find what our b value is. So this is negative 5 over 2. We can come back to the formula right here. So note this is x and this is negative 5 over 2. So we can rewrite this thing here. Get x minus 5 over 2 squared. Oh, and also keep in mind that we're adding, I forgot to write a plus quarter here, so, sorry. So 1 over 4, there we go. And this is equal to 1 over 4. Taking the square root on both sides, we get, so I quickly do that, get x minus 5 over 2 equals plus or minus, evaluating this, we get 1 over the square root of 4 is just 2, so we get this. And again, we'll split this to both cases, where x minus 5 over 2 equals positive half, or x minus 5 over 2 equals negative half. There we go. And you can quickly solve this to get x is equal to, well, let's see, we get, let's add plus 5 halves to both sides, we get x equals 6 over 2, which is just 3. So, okay, our first answer. And on this side we get x is equal to, well, again, let's add negative 5 halves on both sides. So we get 1 half plus 5 over 2, which is 4 over 2, which is 2. There we go. So coming back to our answer, equation, we get this solution.